In this video lecture, we'll be solving this problem House Robber 3, which is a LeetCode medium problem. So in this problem, we have a thief and he has found himself a new place for his thievery again. And that place has only one entrance area that we call as a root. Besides the root, each house has only one parent house. After a tour, the smart thief realized that all the houses in this place forms a tree. That means the houses are connected in the form of a binary tree. And the condition is that it will automatically contact the police if two directly linked houses were broken onto the same night. That means the thief cannot break into adjacent houses at the same night. So what is the problem? We are given the root of a binary tree and we have to return the maximum amount of money the thief can rob without alerting the police. Fine. So that's the problem statement we have here. So let's see the input and output format. And then in the input will be given the root of the binary tree, while in the output we have to return the maximum amount of money the thief can rob. And in the constraints, the number of nodes in the tree are in the range from 1 to 10 raised to the power 4, while the value of the node goes from 0 up to 10 raised to the power 4. So let's better understand the problem statement using an example. So here we have our binary tree. So this is a place where our thief is searching to rob, and this is the root node, and this is the only entrance place to enter this place. And the condition is that in one night the thief cannot rob two adjacent houses. That means if the thief robs this house, then he cannot rob these two houses because they are adjacent to this node. Similarly, if the thief robs this house, then he cannot rob this house and this house. So that's the condition. And the target is to find the maximum money the thief can rob in one night. So the thief has only one night. So if he robs this house, then he can rob this and this house, while these houses cannot be robbed because they are adjacent to each other. And it is given in the problem statement that if the thief robs adjacent houses, then the police will be alerted. So that's the problem statement we are given. How do we solve this problem? So for this particular example, the maximum money the thief can rob is, and let's see the maximum money that the thief can rob for this particular example. So here, if the thief selects the root node or the house at the root node, then he will rob this house. Therefore, he cannot rob these houses, so they are skipped, but he can rob these houses, which gives me a money of 3. Finally, I have a money of 7 units. The another case is the thief do not rob this root node or the house at the root node. Then that means he can rob the houses at this level, which gives me a money of 2 plus 3. But since he robbed these houses, he cannot rob the adjacent houses. Therefore, these houses cannot be robbed now. Therefore, the answer would be 5. And these are the ways for the thief to rob the houses in this colony. And out of these ways, this way is the most optimal because it gives me the most amount of money the thief can rob. And hence the answer for this problem is 7. If the thief enters the root node or the house at the root node, he robs it, then he skips the adjacent houses, and then he robs the houses at the last level while collecting a money of 7 units. Fine. So this is the answer for this particular test case. Let's see how we can solve this problem. So to solve this problem, so think about each node. That means for each node, I have two options. Either I can include it or I cannot include it. Fine. So initially, this is my root node and there are two options that I have. Either I go by including this root node, let's call it with root, the first option, or I go with without root, let's call it our second option. So these are the options that I have while I'm standing at the root house. Then if I select this root node, in that case I have to skip these two houses and move on to the next level, which is here. Otherwise, if I do not select this root node, I have to go down to these two nodes. I can select these nodes if the root node is not selected, and then the logic repeat for these two houses as well. That means now I have this subtree, and for this subtree I again have two options. Either I can include this node or I cannot include this node. And in the similar fashion, there are two options for each node that I am traversing. Fine. That means all I have to do in this tree is to traverse this tree. That means to solve this problem, I have to return a pair from each node. Let's say A, B. So what does this pair represents? This pair for a particular node represents, so what does this pair represents for a particular node? The first element in this pair for that particular node represents the maximum sum of money that I can achieve by including that particular node from the subtree of that node. That's what the first integer is representing. While the second integer represents the maximum sum of money that I can achieve in the subtree of that particular node by excluding the root node of that subtree, because these are the two options I have, and hence I'm returning this particular pair for each node. That's what I have to do here. Fine. Similarly, based on this value, I can calculate the pair for the parent node as well, because so if I have A and B at the parent node, what I want to calculate is the maximum sum by including this particular node, and that has to be achieved by excluding this adjacent node, that is this one. And by excluding this node, the maximum money that is achieved is B, and that constitutes the first integer of the pair for this particular node. And by excluding this node, I'm including this child node, and since I'm including this child node, the maximum sum of money from the subtree, from this subtree, that is this one, achieved by including this node or the root node is A, and that will constitute the second pair for this node. So that's how I have to solve this problem. So how do I implement this task? For that, I have to use depth first search. Why do we use depth first search? Because in depth first search, I start from my root node and I go till the leaf node. From the leaf node, I return my pair. So let's say I start my depth first search from this root node. Then I go to the next node, which is node number 2. So I have visited this node, then I have visited this node, and now I am at this node. And here, what I want to return is the pair. The first element in the pair represents the maximum sum in the subtree of this node, that is this subtree, which I can obtain by including this node, the value at this node, and that sum is actually 3, because in this subtree this is all I have. And the second option is that I am not including this node, and in that case the sum would be 0, the maximum sum in this subtree, by excluding this node, which is 0, and I return this pair from here. Then how would I calculate the pair for this node? To calculate this pair for this node, I have again two options. The first option is that the maximum sum of money in this subtree by including this node, and since I'm including this node, I have to exclude this node. So what is the maximum sum of money that I can obtain in this subtree by excluding this particular node? And that is second integer here in this pair. And what is the second integer? It is 0. And what is the second integer? It is 0. Then I go to the left subtree here. So what is the left subtree? The left subtree for this particular node is empty, and hence I have a pair of 0 0 from the left subtree returned. And since I am including this pair to calculate the first element of the pair for this node, I have to use the second element for this subtree, because that represents the maximum sum of money in this subtree by excluding this particular node, this hypothetical node, and hence this will add 0. So this will give me 0 plus 0, that is 0, and hence I will have 0. That means, and since I'm including this node, I will have 2 here. The final answer would be 2. So this is the maximum sum of money that I can obtain in this subtree by including this node. And this is the first integer in the pair. So I will have first integer as 2. So what is the second integer? The second integer represents the maximum sum of money in the subtree of this node such that this node itself is not included. Since this node is not included, I can include the adjacent nodes. So that means, what is the maximum sum in this subtree by including the root node of this tree, which is 0. Then what is the maximum sum of money in this subtree by including the root node of this subtree, which is 3, because this is the first value here in this pair. And since I'm not including this element, so this would give me 3, and 3 is the second integer. Or if I do not include this node to evaluate the maximum sum in this subtree, then I will get this money as 3. And in this way, I'm calculating the pair for each node. Similarly, so I will return this pair to this node, and this node will recursively call the depth first search function for the right subtree. Then I go deep down to the right subtree, and here at this leaf node, what I'm going to return is, I will return, so what is the first integer? First integer represents the maximum money in this subtree by including this particular node, the root node, and that is 1, because this is the only node that I have in the subtree. And the second integer represents the maximum sum of money in this subtree by not including or excluding this node, so that is 0. So I'm returning this pair to the parent node. Now here again I have two options. I want to calculate the pair for this node, and the first option is that I'm including this node, and since I'm including this node, so assume a hypothetical left subtree which is returning a pair of 0 0. And here you can see that since I want to calculate the maximum sum of values for this particular subtree rooted at this node, so here this one, then the first integer would be simply the second integer here, which is 0, plus the second integer here, which is 0, plus the value at this node, which is 3. Why second integer? Because the second integer represents maximum sum of money in a subtree by not including the root of that subtree, and that's what I want from these nodes. I'm not including these nodes because I am including this node, so that's why it will give me 3. So this is 3 here, and by not including 3, how would I get the answer? The first integer here plus this first integer for this node, so that is going to give me 0 plus 1. The second integer represents if I'm not including this node. If I'm not including this node, then I will take the max of these two values, which is 0, plus max of these two values, which is 1, and it will give me 1. Why? Because that's what I want, the maximum of the two options for the left subtree and for the right subtree, and hence 1 is the second integer for this particular node. So finally, what are the equations that I have? So since I'm getting a pair from each node, the first pair, let's call it FP for a particular node. So the first element in the pair for a particular node, let's call it root, is evaluated by adding the value of the root, the second value of the pair from the left subtree, and the second value from the pair of the right subtree. So this is how I obtain my first value in the pair for the root, while the second value in the pair for that particular node, call it root, is obtained by not including the value of the root. Since I'm not including the value of the root, I want to include the maximum of the values of the pair for left subtree and maximum of the values of the pair for the right subtree. That means max of left pair plus max of right pair. So these are the two values that I obtain for a particular node. And for this node, the first value would be 3 plus 3 plus 1, and that is going to give me 7. And the second value would be max of these two, which is 3, plus max of these two, which is 3 and 6. So this is the pair that I will obtain for my root node, and the first element represents the maximum sum of money in this entire tree by including the root node, while the second integer represents the maximum sum of money in this entire tree by excluding this root node. And what is the best option out of these two? Obviously the first one, that is by including the root node, and hence the answer would be 7. So that's how I'm obtaining the answer for this particular example, and I'm using depth first search strategy to solve this problem. Let's implement this solution in the next slide. So here we have the implementation for that particular solution for my explanation. So this is the house robber function which takes in the root node. This is the base condition I'm handling where I am reaching the leaf node. Since I am reaching the leaf node or I have an empty tree, in that case I'm returning a pair of 0 0. That means even if by including a null node or not including a null node, the value stays the same, that is 0. Then I explore my two options. The first option is obtain the pair for the left subtree, obtain the pair for the right subtree, and finally evaluate the pair for the subtree rooted at this root node using these pairs p1 and p2. The first option is, that is the first element of the pair for this subtree rooted at this root node would be including the root node plus the second element of the left pair and the second element of the right pair. This will give me the first element for my root node. That is, I'm including this root node, and the second option is I'm not including this root node. And in that case, I will take the max of the pair for the left subtree and max of the pair for the right subtree, and I will add both of them. Fine. And finally, I will return my p pair from this function, and in the calling function I will get p as returned, and I will return p dot first, and in the calling function which is calling this house robber function, by passing in this root, I have to return max of the first element of this pair is p dot first and the second element of this pair, that is p dot second, and this is my answer. Fine. Let's move on to the code implementation. So this is the solution class where this is the tree node structure, and we have two functions here. The first function is this rob function which takes in the root and gives me the integer representing the maximum money the thief can achieve, while the second function is solve function or the helper function which returns me the pair for each node, and hence this will return me the pair for the root node that I passed. So let's define this solve function or the helper function which I explained in the slides. So I'll first handle the base case. If I get to leaf node, I'm returning a pair 0 0. Then I will recursively call this function for the left and right subtree and obtain the pairs p1 and p2 for those. Then I will find the first element of the pair p for the current tree rooted at root by including the value for this root tree, by including the value for this root node, and the second value is obtained by the maximum of the pair for the right and maximum of the pair for the left subtree. Finally, I will return my pair right from here, and here in this rob function I will simply call this helper function while passing in the root, which will return me the pair for that particular tree rooted at root, and then I will return the max of the elements of this pair, and that will be my answer. Easy problem. Let's see the implementation in C. This is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.